So let's look in the types of quadrilaterals. So there are 1, 2, 3, 4, 5, 6, 7. So first we'll begin with kite. So kite, the word you guys know, it is nothing but kite. The specific properties related to this particular quadrilateral is that two pairs of adjacent sides are equal. If I name this as AB, CD, AB is equal to AD and BC is equal to CD. Only two pairs, not all the sides, not opposite sides, adjacent, neighboring sides. One more important property over here is the diagonals, they intersect each other at an angle of 90 degree. Okay, so you can see over here, they are intersecting each other at an angle of 90 degree. Okay, there's one more property that BO is equal to OD. Okay, so one of the diagonal gets bisected. So that I won't go into that now, it will be too much. So, and one last thing is, wherever you see any quadrilateral wherein the diagonals are bisecting each other, the area can be given as half of D1 into D2, where D1 and D2 are your diagonals. So there are two diagonals, right, in a quadrilateral. The product of those two diagonals divided by 2 will give you the area of this particular quadrilateral. So in whichever quadrilateral you get to see that the diagonals are bisecting each other, so you can use this particular area formula. Okay, so this is about your kite. Kite has quite a few things, and people don't remember this much, but yes, any tricky question they go to kite and you guys will get confused. So see to that you remember all of these properties. Okay, next is a trapezium. So trapezium is quite simple. So trapezium is a quadrilateral wherein one pair of opposite side is parallel. That's it. So here AB is parallel to CD. That's all. And the distance between two parallel lines, we are taking it as h. Okay. So here with this in mind, right, the length being A and B, the parallel lengths being A and B, and the height, the distance between them being h, we can find the area of the trapezium using the formula half of h1 into A plus B. That is sum of parallel sides into the distance between them divided by half will give you the area of this trapezium. So this is something that you guys have to remember. And we know that co-interior angles of a parallel of any given set of parallel lines, they add up to 180 degree. It's like this is an extension of that property. So this is not a fancy new thing. This is an extension of any parallel lines. So these are your first set of level 1 type of quadrilaterals. So borrowing this property, we have quite a few things over here. So whatever properties we are seeing over here, that is by default present in this and this. So parallelogram will have a property of this particular trapezium, and this isosceles trapezium will have a property of this trapezium, and much more. Remember that. So this rectangle will have a property of this parallelogram, which in turn has a property of trapezium. So this rectangle will have a property of this trapezium as well. Okay, so it's like an generation. Okay, next we'll see the parallelogram. No, let us see isosceles trapezium. In an isosceles trapezium, the extra condition is that the opposite pair, the non-parallel sides pair, they will be equal. So in this case, ABCD is your trapezium, wherein AB is parallel to DC, AD is equal to BC. Okay, so this is the extra property. And next thing is that the diagonals over here will be equal. Here the diagonals won't be equal, here it will be equal. So that is the extra property. So diagonals are equal. Okay, I'm trying to list things which are quite easy. Of course, there are quite a few things that we need to know, but I'm listing things which are used often and just to introduce you guys, not too many things. So there might be extra properties which I'm not listing that we'll get to learn and use in time. So looking at your parallelogram, by default it will have a property of all of this. Okay, so we can use this condition and all of this, use this formula and use this condition. So all that will be there by default. So extra in parallelogram, we have opposite sides to be equal, opposite angles to be equal, and opposite sides to be parallel as well. So with all of this, we have diagonals which bisects each other. So this is the extra property. So here the diagonals will cut each other into two equal halves. Okay. Now borrowing the property of kite and parallelogram is your rhombus. So in this, opposite sides are equal like in parallelogram, and also adjacent sides are equal like in kite, and thus all the sides are equal. Borrowing from parallelogram, we have opposite sides to be parallel. Borrowing from kite, we have the diagonals cutting each other at an angle of 90 degree. Borrowing from parallelogram, the diagonals will bisect each other at O. Means what? They are cutting each other into two equal parts. And next we have rectangle, which borrows all the properties of parallelogram, plus additionally the diagonals are equal and the angles are of 90 degree. Okay, so opposite sides are equal, opposite sides are parallel. So along with that, angles are 90 degree and the diagonals are equal. They bisect, they cut each other into two equal parts, and also they are of equal length. So borrowing property of pretty much everything over here is your square, which has all the sides to be equal, all the angles to be equal and equal to 90 degree. The diagonals are equal and they cut each other, right? And they are parallel and so on and so forth. Okay. So listing the below ones is quite simple. The top ones is confusing. Okay. So here if I name this as O, BO will be equal to OD. So this is an extra bit. I think we should know this. The one of the diagonal will get cut to two equal half by the other diagonal. But AO is not equal to OC. Okay, this also you guys need to remember. Okay, so here this angle and this set of angle, they are equal. Wait, so this is more than no, I did that wrong. So this is an extra bit. So what we have over here is this particular angle is equal to this particular angle, and angle D is equal to angle C. This is something that we need to remember. So there are quite a few things that we need to remember and use. Okay, so pause and have a look at the properties of a list of quadrilaterals actually. And you need to copy this as well.